Okay, welcome back to the channel, folks. Today we're going to talk about generator cord wiring. Now I just want to remind you that this is for entertainment purposes only. You should always consult on your own local electrician certified to check out the cord wiring, but this is just to demonstrate how we do it, and this is just to save you from buying one if you'd rather make one up. So stick around and enjoy the show. How to wire a new residential construction. Okay, so the next portion of this is the actual cord that makes up the generator. This is called, or the generator cord. This is actually called SOW cable. It's a flexible, wax-covered, sun-resistant exterior wire made by NEMA, and this sometimes is what we supply for a customer when they need a longer length than what you can buy in the hardware store. So we can make up predetermined lengths, and the quality is a little bit better too. Now the key when purchasing this SOW cable is a little bit different from regular Romex or NMD cable that you would buy for house wiring. If you ask for a piece of 10-3, this is 10 gauge, so it's rated for 30 amps, which is what we're going to do with our receptacles. If you ask for a piece of 10-3, they will give you a piece of wire with 3 conductors in it. So you only get the white, the black, and the green. With SOW cables, you need to ask for that 4th conductor. So you need to ask for a piece of 10-4 SOW cable. This will give you the black, the white, the red, and the green. You need the black and the red for the 240 connection, the white for the neutral connection, and the green for the ground. So make sure when you ask for this, or your electrician will know that this is what they should be asking for to work properly with this cord end that we're going to make up. Now I'm not going to unravel this. You can see it's about 50 feet. So we're just going to do the ends. So the tools that are going to be needed for this, and all plugs are a little bit different, is a star-shaped or a Phillips screwdriver, probably a number 1 Robinson, a pair of electrician strippers, a meter, some sort of a sharp knife to strip the SOW, and a pair of linesman pliers. So we're going to take our sharp knife, I'll move up closer here, I'm going to strip the end of this cable. Now the key to stripping the end of this cable is we only want to go back about 2.5 inches. We want to go around the whole outside of the cable, and we want to be careful when we're doing this. We don't cut ourselves, and we don't score into the internal conductors of the cable. So we just want to lightly go around to score it on the outside, and then we're going to want to put a slit in it. And that slit will allow you to get that off to expose the conductors. Boy, this got a lot of chalk in it. Whew, probably the most I've ever seen out of any conductor. So now we have 4 cables. We have the green, we have the red, we have the white, and we have the black. So the green is going to go on the obviously green terminal on one of the ends of the outlet. The white is going to go to W for white, and then X and Y on the outlet are going to be red or black. It doesn't matter as long as we get those 2 correct. So before we do that, we're going to want to strip the end of each conductor to expose the bare copper, probably about 1/2 to maybe 5/8 of an inch. And we're going to twist them counterclockwise so we don't get frays when we go to put it on the end of the outlet. If we had a sharp pair of cutters, we'd be able to get this off a little bit better. It's making me look like a fool here. There we go. And then the green. And then the black. So just a little food for thought. Sometimes you can find deals on these pre-made cords cheaper than you can actually make them for. But generally you're going to pay about $100 for one of these cords. To make them up, you can probably do it for about $80. So now we have all 4 ends. And we're going to take one of our ends, one of our receptacle ends, which is the female. This is the end that's going to plug into the house. So 2 screws on the end. We're going to loosen them off to expose the wires or the contacts inside. Now I should note that this only goes back together one way, because on the end there's a little tab here I'm going to show you. If I can get it out. There's a little tab right there. You can see with my thumb, my middle finger, that has to line up in order to go back together correctly for everything to fit together. So I'll finish taking it apart. Get it completely out of there, and then you see on the back we have the green, which obviously goes to the green wire. Then we have the white. I don't know if you can see that or not. Yeah, W, it's upside down, so I actually make a W there. And then X on the top and Y on the bottom. So that's the configuration. Now, the end of this is just a little strain relief. That's why we only went back so far with this conductor, because we want a good connection in the end, so it sits like that in the end of the wire. So we're going to poke those out, but not tighten things down. And then we're going to attach our first end. So the green is going to go under the green. We're going to shove it in and tighten it down thoroughly. So we're from Canada. It's cold up here in Canada today. It's the middle of January. The temperatures are dropped down quite a bit. And then we're going to do, let's go with red on X. And it really doesn't matter on the other end, but we'll do red on X on the other end as well. So we're going to tighten down the red. Just going to move this camera down just ever so slightly. There we go. Okay. And a good note is to check each connection as you're putting them in underneath the screw terminals to make sure that they're tight and they're actually pinching down. This one has guides so it can slide right in. Yeah. I'm going to make sure that's tightened down real good. And then last but not least, the white, which is the most important. You don't want to lose this on a generator connection because all kinds of bad things can happen to your home. So you need to make sure that you have this neutral connection and it's in there good and tight. That looks good. So what I've done is I've put all 4 wires in the back of this receptacle end. This is the receptacle end. And now we're going to sleeve things back up over. Get things lined up. Should also note that on this particular receptacle there's a little tab here that has to line up with the outside part of the tab on the receptacle in order for the screws to go back together. And then that's the outside of that. Now that will fasten that to the outer part. We can start our screws back in. Should drop right into place. And then the back, the strain relief connector needs to go back on. Needs to fit in here nice and tight. And we need to look for that tab that I mentioned earlier. which is right there. Get that lined up, and then that all should go together. Now the stream relief on the back, let's get these screws started. This one's being fussy. There it goes. That's what we want. That ensures it's good and solid. Stream relief on the back. We just want to pop that into place to make sure it's good on the end. And then what you end up with is that all put together nice and pretty with the stream relief on the back. Sometimes they're a bit finicky, but pretty straightforward. Give it one good tighten up to make sure it's not coming apart. That's one solid generator end, and that is the female that will plug into the twist lock on the generator rated receptacle, which is an L14-30R on the side of a house. And we're going to do the same thing we just did with the positive end, or sorry, the male end. So we're going to strip that back. Check to make sure we don't score any conductors. Always cut away from you so it'll come off. Whew. Pull that off, strip the wires. Now it's important to pay attention to this part because we don't want to crisscross any wires because that would be bad. But that's what the meter's for at the end of this process, so we can test our check our work basically. Excuse me. Okay. So now we're going to do the same thing only with the male end, and this is the end like I showed you that plugs into the generator. Generator should have a designated L14-30R configuration, and it should be fairly straightforward. Most generators with this configuration are usually rated between, we've seen them as small as, well, 6,000 watts or 6,500 watts right up through till 12 or 13,000 watts. A little generator helpful hint while I'm doing this here. 30 amps is actually 7,200 watts of power that you can produce, 240 volt. And a lot of people don't know this, but that's a lot of power. So in order for a generator to produce 7,200 watts continuous, you need at least a 10,000 watt generator. And the reason for that is the ratings on these generators that you see are usually peak. So if you buy a 7,500 watt generator expecting to put out 7,200 watts or 30 amps, you might be in for a surprise because the generator is going to be laboring so hard it's just going to kick the breaker out or bog the engine down. So as a rule of thumb, the bigger generator the better. You'll find these generators, well, I get on there. There we go. You'll find these generators right up to 12,000 watt with the 30 amp receptacles on, and that's for the reason. Even though they're on a 30 amp breaker, that's actually 7,200 watts, like I mentioned. You need that big in order for it to work. So long story short, bigger is better in this situation. And a proper electrician, when they're putting in the generator panel or the transfer or whatever they're doing for you, well, they should do a load test on the system, on the house with the generator running, because the key to having the most successful running generator is to have it that both legs of this 240 volt are loaded up equally. So if you have one leg of 120 volt that's loaded up to 30 amps and the other leg of 120 volt between the 240 that's loaded up to say 5 amps, you're wasting 25 amps on that one side of the generator. So usually we'll try to balance a home, we call it home balancing, say, you know, 20 and 18, or, you know, as close as we can get them. We'll shuffle breakers around in the customer's panel until we get close, and that really equals out the generator as much as possible to give you most bang for your buck, burn your fuel more efficiently, and make sure it all works properly. So I'm just finishing up this last black one, and this is on the X. Really doesn't matter, I mentioned to you before, but the key is to get these terminals in here properly. Make sure they're good and tight. So now we have them all on the back of this male side, and we're going to line everything back up. I'm just going to look for the end here. We're going to push it all back together, line the screws in the holes. It's hard to do this and show you guys at the same time, but I'm getting better with the camera. That crimps and pushes all down, and then the screws will drop back into place, and then you tighten your screws. Again, make sure they're tight. Now all these outlets are a little bit different depending on the manufacturer, a little bit different ways to do it, but you get the gist of it. They're all pretty much the same. We're going to make this that it really goes in there. Yeah. Yeah. That one went together good. And we have the same thing. We have the sealed end to keep the water out. We have the end on this side, which is the male. Now, checking your work. We have two ends now. Male, female. Take your multimeter tool. If you don't have any, you can get them quite cheaply from the hardware store, about 30-40 bucks. This is a Klein one, so it's a higher end one. Basically, you're going to put the meter on ohms, the little horseshoe guy, and what that's going to do is that's going to give you a beep when you touch the two terminals together, like that. So that's the beep you're going to listen for. What you're going to do is you're going to check from each wire to make sure you have it correct. So we're going to start with, I believe this is the ground in this situation. Yep. And we're going to listen for a beep. So we're going to check on each end. So you can see I've stuck it through the ground on this one, and I've stuck it in the ground on that one. So that tells me I have that one correct. Excuse me. Then we're going to move across to the neutral, which is on the opposite end of the receptacle. And we're going to do the same on this. Oh, look at that beep. So we have it correct. The X and Y really don't matter, but you can test them anyway. Whoops. That one there. So I'm on the right and on the right. So basically, I have one lead. Oh, that's really hard to focus. There we go. I have one lead in there and one lead over on one of the extra Ys. As long as we determine. The key to that, the most important part, is to make sure that you have your ground and your neutral correct, to make sure that you don't have them mixed up, because that is the most important part. And guess what? That is it. We now have a generator cord ready to go for the customer. I'll put some links in the description down below to the parts, and also for some pre-made cords for some good deals. But remember, always check with your local certified electrician that you've done this correctly, or seek professional advice. Alright, so that's it. Don't forget to like and subscribe, and we'll see you next time.